Hello and welcome to another fun-filled video in Math with Mr. Sims. This is your Cycle 13 test incentive video. So this is the test incentive for the test that you're going to take January, 15th or 16th? Basically this Friday. I really do hope that this goes well for you. Once again, I'm going to try and make this video about 30 minutes long. After we get started, and I'm going to just knock out as many prompts as I can. My suggestion is, once again, make sure you have paper and pencil handy. Take the notes so that you can get the credit. Let's do the first thing first. In the upper right hand corner, go ahead and write your name, first and last name, your period, right, and your teacher's name underneath that. Then write Cycle 13 test incentive at the very top of your page, right? And in the bottom right hand corner, draw a it's a nice time of year. It's almost spring. Let's go ahead and draw a flower. Go ahead and draw a flower, just some type of daisy or some type of flower. In the bottom right hand corner, once again, draw a flower. And in the bottom left hand corner, say I'm going to ace this test. Okay, so you can say in the bottom left hand corner, I'm going to ace this test. All right, so anyway, I hope you're having a great day. Like I said, I want you to be able to knock this out. So let's go ahead and get started without further ado. And like I said, I'm going to basically try and get as much as I can done in 30 minutes. Let me just
make sure my thing's all working. It looks like it is. All right, perfect. All right, here we go. Alexa, set a timer for 30 minutes. Awesome.
Okay, so here we go. This first problem says identify the slope and y-intercept from the following equation. So it says 4x plus 5y is equal to negative 10. Now, you might be tempted to say that this is the slope right here, but you would be incorrect because right now this form is in standard form, and we do not want it in standard form. What we want is we want it in slope-intercept form, because standard form, you can't find the slope from this. So what I need to do is get it into slope-intercept form, which is going to be, y is equal to m x plus b. If I can get it into y is equal to mx plus b, then I'm going to be able to find out what the slope is. So if I start with 4x plus 5y is equal to negative 10, then my first step then is going to be to figure out what do I need to do first. So it looks like first thing I want to do is solve for y. Basically, I want to get it into y is equal to mx plus b form. So I'm going to start by subtracting 4x from both sides, right, to get my y term alone, right? Subtracting 4x from both sides. And I want you to remember that you cannot combine these two. This is like negative 10 something. This is negative 4 bags of something, right? So it's negative 4 groups of something. So you can't combine those two. So what I get here is I get 5y is equal to negative 4x minus 10. All right, which now I'm going to divide by 5. I'm going to divide everything by 5. And this cancels out. I get y is equal to negative 4/5 x minus 2. All right, now at this point, I now have the slope. Remember, the slope is what's attached to the x, and I have my y-intercept. So let me start with my slope. My slope is negative 4/5. It looks like the only one with the slope of negative 4/5 is D. This one has the wrong slope. This one has the wrong slope and the wrong slope. So that's actually my answer. Let me just double check my y-intercept of negative 2. Yep, your y-intercept is the b, right, of the y is equal to mx plus b, so negative 2 is the answer. All right, so hopefully that made sense to you. Let's go ahead and move on to question number 3. Question number 3 says the graph of the function of g is a result of a transformation of the function f. So it's telling us that g came from f. That's important, all right? So here's my g. It's labeled here. This is my g line, and this is my f line, as it says, right? So what's happening to f to get to g? Well, there's two ways that this movement could be accomplished. You could move it to the right, or you could move it down for this line. And I'm not sure exactly which one it is. So what I want to do is I want to actually look at which of these is the best represents transformation, and I want to look at which one that would be. Now I want to just take a moment to remind you that basically if you have g of x is equal to something times f of x. If you have that, right, where you have some number multiplied times f of x, then what this is called a twist, or you might call it a stretch, right? So this would be a twist or a stretch, all right? Now, if you have g of x, right? Sorry about the handwriting, is equal to f of x, and then you subtract, or maybe you add something to it, right? You add some other number, just tacked on at the end. If that's the case, then what you're looking at is you are looking at a, what's the word I'm looking for? Yeah, if it's just tacked on the end, you're looking at some type of vertical transformation. That means it's either going up or it's going down, right? And then finally, if you have g of x is equal to f, and then in parentheses you have x minus or plus something, right? Whatever it is, minus or plus some other number, then in this case here, you're either going left or right, okay? Make sense? And if this number is a positive number, then you're actually going to be going left. It's actually the opposite of what you think. If it's a positive number, you'd be moving it left. If it's a negative number, you're moving it right. In this case, if it's a positive number, you're going to be moving it up. If it's a negative number, you'd be moving it down. And the twist or stretch, you're going to basically multiply times whatever you got there, okay? So anyway, so once again, if it's multiplied times the f of x, you twist it. If it's added just or subtracted at the end, but not in the parentheses with the x, then it goes up or down. If it's in parentheses with the x, it's going to shift the graph left or right, the line left or right, all right? So let's go ahead and look at this one here. So this one here, you have plus 1 at the end. So this would actually move this whole line up. It would basically look something like, wow, that was horrible. It basically looks something like this here. That's not the right answer. There we go. The line would look something like that, basically moved up 1, right? So that's not it. This one here would be changing the slope times 1, right? Which actually, since the slope is 1, that wouldn't do anything to it. This one here is f of x minus 1, so this would actually be moving the whole line down 1, which actually looks like it probably accomplishes what we want. But let's go ahead and check this one. This one would actually change the slope to negative 1. So then my whole line would basically look like this here. And that's not what happened with the line. That would be a twist, right? So the answer is, for this one, H, because the whole line moved down 1. So it didn't end up doing this one here. It ended up doing this one where it moved down 1, all right? But once again, we didn't know. It could have moved down or right. Both of them would accomplish the same thing. But in this case, it was fx minus 1. If it had moved to the right, it would have been...
Why did my thing not work? Let me try that again. So if it had been to the... Why is my drawing not working anymore? This isn't... Oh, I'm on the erase still. Here we go. Let me try that again. Yeah, victory is mine. Okay.
So if it had been, like I said, a move to the right, then it would have been g of x is equal to f of x minus 1, which would have made it shift to the right one, okay? So then it would have been in the parentheses with it. But it wasn't that. It was, in fact, H, so H is my correct answer. Let's go ahead and move on to 4. So 4 says, which of the following is the graph of x plus 3y is equal to 9? So if you have that there, once again, x plus 3y is equal to 9 is very hard for me to see off the bat. I don't know exactly what that graph would be. So I need to do some work to get to be able to see what that is, because this is right now in what we call standard form, and it's hard to see what what the lines are going to look like in standard form. So I'm going to turn it to slope intercept form so I can get it. So what I'm going to do is I'm going to take my x plus 3y is equal to 9. Always be careful when you copy it again, right? Because you could make mistakes there. I'm going to subtract x from both sides. Once again, I cannot combine this negative x and the 9. So it's just going to be 3y is equal to negative x. This is a negative x plus 9, right? Then I'm going to divide by 3, and divide by 3. So what I should get, is, I'm going to write it right down here because I ran out of room, y is equal to, really it's negative 1/3, right? X plus 9 divided by 3 is 3. So my y-intercept is 3. So I'm going to start off by that and say, all right, is there a y-intercept of 3 that I can look at? Let me just go ahead and zoom out a little bit. So y-intercept of 3. This one has a y-intercept of 3. This one has a y-intercept of 3. And this one also has a y-intercept of 3. And this one has, so that actually doesn't help us at all. Okay, well, good to know. I checked it out, though. This one got a slope, though, of negative 1/3. So I'm looking for a negative slope. This is clearly a positive slope here, right? So this is a positive slope, so that one's out. This one is a negative slope, so it's a possibility. This one, once again, is a positive slope, right? Positive slope, so this is out as well, right? And so once again, C is out, A is out, which means either B or D. Both of these have a slope of that's negative, but I need to look. I need a negative 1/3. That means it's going to go down 1, right? Because it's a negative slope, so it's down 1, and it's going to go right how much? Right 3. So down 1 and to the right 3. So this one looks like down 1 and to the right 3. In fact, that one's probably my answer. Let me go ahead and zoom in just to make sure I got that right. But down 1 and to the right 1, 2, 3. That actually looks like it's probably it. Down 1 and to the right 1, 2, 3. But I always like to check my other answer just to make sure. This one's definitely down 3 to the right 1. So this would actually be a negative 3/1 slope. And that's not what we're looking for. We wanted the negative 1/3. So the answer is D. D is the correct answer for that question. All right. Let's go ahead and move on. D. 6 says graph function g as the result of a transformation of the function f that is given below. And they tell us what the transformation is. They say this transformation is negative 3. You have your f of x and you're subtracting 3 from it. Well, as I said up here, right? Oh, I erased it. Well, as I said up there, if you have something just tacked onto the end like that, right? Then that's called a vertical transformation, right? If what you have is f of x and you have either plus or minus something, then what you're doing is you are changing it vertically. You're moving the line up or down. So in this case, that minus 3 is going to mean that it goes down 3. So I need to look now at the F1. Remember, it's going from F to G. So here's my F line. Here's my G line. And this one looks like it's actually going up 3. So that's actually the opposite of what we're looking for. This one here would actually be a twist, right? And it's actually a weird twist as well. It'd be twisting around some weird spot. So this one's just way out. This one's out once again because this is the wrong direction. This one here would be a twist, right? Changing the slope from here to this, right? Which is also out, because to accomplish that, basically what I'd be doing is I'd be multiplying the whole thing. So I would need something on this end multiplied times the f of x. This one here, the f goes down by exactly 3. So that tells me that's the minus 3 I'm looking for. That's the down 3. So the answer is D. All right? All right, let's go ahead and do this one. Which of the following lies in the solution set for the systems of inequalities? So for this one, what I have to do here, let's see how I want to do this. All right, so for this one, first of all, the first thing I'm going to do is I'm going to graph my line, and I'm going to realize that both of my lines are going to be dotted lines. So in other words, this line here is dotted because there's no equal to. If there was an equal to, it would be a solid line. If there was an equal to, once again, it'd be a solid line. So this one's going to be dotted. Not only is it going to be dotted, it says y is greater than. So since it's going to be greater than, it's going to be shaded above. So I'm going to shade above the line, all right? This one says y is less than. There's no equal to, so it's also dotted. And I'm going to shade below the line. So let's go ahead and do the first one. The first one says y is greater than negative x minus 2. So I'm going to start off at my y-intercept of negative 2, which is right here, right? That's my y-intercept, negative 2. And now I'm going a slope of negative 1. This is really negative 1x. So my slope is negative 1. So it's down 1 over 1, right? Which brings me to my next point. Down 1 over 1, which brings me to my next point, and so on. And so if I were to actually draw this line, my line would basically look like that. All right, so that's my first line. Now my next one starts at plus 2. So here's the plus 2. And my slope is negative 5 over 1. So it's going down 1, 2, 3, 4, 5, and over 1. So it looks like this right here is my point of intersection. And if I wanted to go ahead and draw that line now, it would basically look like that, right? And it look like, let me finish that line. So it basically looked like that. But once again, my point of intersection is right here. I can actually change the color just to make that a little bit neater. Is right here is my point of intersection. So I have to look at what are the coordinate pairs of that point. Well, it looks like 1, negative 3. So, Oh, yes, so that's the intersection point, but I started doing that wrong. I'm sorry. It said which of the solution sets lies in the solution set for the system of inequalities. So Mr. Sims, geez, you almost made a horrible mistake. So once again, this first line that we made, the negative x minus 2, I forgot I have to shade above, right? So
If I had to shade above it, let me go ahead and go to my layer down here so I can shade above it. I'm going to change my thing size. I'm going to shade all above this line here. Let me move this layer up just a little bit too. So I happen to do some quick thinking here. And this is going to be basically just lighten. Right? Oh, that didn't work. Let me try that again. No, no, no. Where'd my layer go? It disappeared. All right, let me move it back up. So there's my coloring layer. And what I'm going to do is I'm just going to change the visibility of that coloring layer because, except I can't. Or maybe I can. Haha, there's my victory. Okay, so there's my coloring layer yellow. And I'm just going to go ahead and color all above that. So, okay, anything up here, basically, it would be true of that. It's all shaded above the line, right? So then I draw my second line. My second line, if I go to writing, right, my second line is, I'm going to make it purple. So this is the purple one here. Okay.
my second line is negative 5x plus 2. So once again, I go up to plus 2, right? And I go negative 5x. So I go down 5 over 1, which puts me right there. And so this is my line. Now remember, both of these lines actually are supposed to be, they're both supposed to be dotted lines, all right? So
I'm going to actually have to make both of these dotted now. And so let me go ahead and make them dotted, right? You can see they're dotted lines now, right? Cool, huh? Yeah. And this one's also got to be a dotted line because it can't actually include those lines because like we said, they have to be dotted, right? And like I said, let's go ahead and do this. All right, so going up.
over here now, I got to shade below the line for this one here. So if I'm shading below negative 5x plus 2, I'm going to shade that one blue.
All right, let's see what happens. So I'm going to shade it blue. I'm going to make it this blue. Why not? Because I like it. Let me do that blue, actually. And then I'm going to, once again, do this in the coloring. And I'm going to make that about 500. And let's go ahead and shade below this line now. So this is below this line. Now, if you're struggling with what's above and what's below, that did not work. Hold on a sec. Let me try this again. Let me go ahead and make one more layer called, no, I didn't want that. That's not it. Control Z. Let me make one more layer. I'm going to call this coloring 2. All right. So this one here, so I haven't had to do shading like this in a long time. So if I want to do this one, I'm going to make this one have an opacity of about 30 as well. And basically, yeah, look at that. That's better. So now when I actually put those together, you can see that those make green, right? So I have my green here. So that's shaded below that line now.
So this overlap is actually the solution set. You'll see it's this beautiful green color that's formed here. So if I want to know if it lies in the solution set, now they want me to plot all these different points, right? So I'm going to go ahead and plot the first point. The first point is, let's see, the first point is 1, negative 1. So 1, negative 1 is this point here. And that is clearly not in my solution set, right? Because if it was in my solution set, it would be inside this green. So that is not in my solution set. I'm going to go to my next one, 0, negative 3. 0, negative 3 is way down here. Also, once again, not in my solution set. C, 2, comma 4, 2, 4 is way up here, and once again, also not in my solution set. Finally, let's go negative 2, comma 2. Negative 2, negative 2, comma 2 is right there, slap dab in the middle of that beautiful green region. Ergo, this is the, what? That's the solution. So that's the one that lies in the solution set. So once again, you plot the lines. Don't forget to do your shading. Get your shading in the right spot. The overlapping portion is where these dots have to be in, okay? All right, so I'm going to move on. Today, the temperature in New York is a balmy negative 1 degrees. Just kidding. That's terrible. So today, the temperature in New York is negative 1 degree. All right. Sorry. And is expected to rise 3 degrees per day. It's 6 degrees in Alaska and expected to fall 5 degrees every day. After how many days will the temperature in both New York and Alaska be the same? And what is that temperature? Use the blanks below to help you. So this one's actually an application one. This is how you might actually use that whole graphing to find the system of equations, right? So let's go ahead and do it step by step. This is going to be a little bit of a pain in the bottom, but let's go ahead and work with it. So today the temperature in New York is negative 1 degree. So negative 1 degree is actually kind of like my starting point. All right, that's going to be my B. It's the negative 1 degree. It's expected to rise 3 degrees per day. That 3 degrees per day is my slope. Basically, every day it's going up 3 degrees. So my slope is 3. Therefore, if I have my equation in y is equal to mx plus b, right? I have my y-intercept and my slope, my b and my m. So I'm just going to make it y is equal to 3x minus 1. Hopefully you understood how I did that, right? Once again, negative 1 was our starting point, and 3 was the rise each day. Now, it's 6 degrees in Alaska, so the starting point in Alaska is actually 6. And it's expected to fall 5 degrees every day. So this slope actually has to be a negative 5 degrees, right? And so once again, if I'm doing this, this would be y is equal to negative 5x plus 6. Now, if you're freaking out about this problem, you're right. This is a tough problem. This is an application problem where you actually use this stuff. But you can get it. Just focus here for a second. Now, we're going to graph both equations. So if I wanted to graph both equations, let me start with the New York one. I want to make the New York one a nice purple. Okay, so I'm going to put a dot above New York to show that it's the purple one. And it's 3x minus 1. So I start at minus 1 here, right? And I'm going to go ahead and do a slope of 3. So my slope is up 1, 2, 3, and over 1, right? I'm going to put another dot, right? Then 1, 2, 3, and over 1. So here's my beautiful point, right? This is my starting point. And I'm going to go ahead and draw the rest of the line that I had, right? And let me go ahead and finish it up here as well. So that's basically my line going through that. That's for New York, so that's the line for New York. The line for Alaska is, let's see, negative 5, 6. So it starts off with a y-intercept of 6. So I'm going to go up to my y-intercept of 6. I'm going to make this one a nice mauve. I don't know what color that is. Maybe it's mauve, fuchsia. I don't know. So I'm going to go to 6. And it looks like my slope is down 5 over 1. 1, 2, 3, 4, 5, and over 1, which is going to be right here, which is not on it, right? So I'm going to go ahead and draw that line. And you know what? That doesn't look like a really pretty point to me. I'm not
sure that actually is. You know what? Here, let me do this. Let me go ahead and make these lines just a little bit smaller and see if I can get a more accurate line for us, right? Let me go ahead and make it 10 maybe. I'm going to start once again with the purple one. So the purple one is negative 1, right? And the second one is, the slope was 3, right? So I went up to there, 1, 2, 3, and over 1. And 1, 2, 3, and over 1. I'm going to go ahead and draw my line through it, see if I can get a more accurate line that's going to help us out. All right, the other one, I'm going to make that fuchsia color once again. I start at 6, which is right here. And I'm going to go negative 5, so down 5 over 1. So actually, 1, 2, 3, 4, 5, and over 1. So as I suspected, actually, it's not a particularly perfect point. In fact, it looks like the intersection is right about there, which is just ugly. So what is that temperature, right? That temperature, it looks like, honestly, is about, what's that going to be? So it looks like after about 1 day, maybe like half a day, and the temperature looks like it's going to be about 1.5 maybe, right? So maybe it'll be about 1.5 after, I don't know, after maybe half a day. I don't know, I feel like these numbers are wrong. But anyway, that gives you the idea of how you do it. I think the numbers that you have, if you have a problem like this on your test, are going to be a lot nicer, okay? So don't be worried too much. This is actually how you solve it, though. Basically, I started with my equation, right, recognizing that it's expected to rise 3 every day, so 3 over 1, right? From the negative 1 degree, and then this one here, remember, it's 6 degrees in Alaska, and it falls 5 degrees every day. So that's a negative 5 slope. So anyway, this is all right, but the point that you get when you do it is just ugly. In fact, if I wanted to get the exact point, hold on, let me pause the video real quick. Alright, just do it with the calculator to make sure I'm not making any mistakes. And sure enough, when you try and get the answer to this, it is ugly.
The answer ends up being after 0.875 days. Wow, that is so ugly. So after 0.875 days, that's 8. That's supposed to be an 8. Pretend that's an 8. I'll erase it. Alright, so after 0.875 days, it looks like the temperature becomes, so after these many days, temperature is going to be 1.625 degrees Celsius. And so, as you can see, that's a very ugly number. I believe the one on your test is going to be much, much, much easier, right? So don't freak out too much about that. But that is how you solve it. You basically graph the lines and look for the intersection point, okay? All right, here we go. Let's go ahead and do another one. What is the solution to the system of equations? So this one here, I have to find the solution to the system of equations. The way I'm going to do that is this. I'm going to start by drawing my lines. I'm going to do that with this pen. So 4x plus 3, right? I start at plus 3. Okay. Why is that not working? Because I'm still on the eraser. So once again, I go to plus 3. And I get 4x plus 3, so I'm going to go up 4 from there and over 1. But unfortunately, I can't do that. It takes me off the graph, so I have to go down 4. 1, 2, 3, 4, and to the left 1, right? And that is my beautiful line there, basically. That is the line that I'm using. And this one is negative x minus 2. So if this is negative x minus 2, I'm going to start at negative 2. right? And I'm going down 1 over 1 because that's my slope of -1, right? So I go down 1 over 1, down 1 over 1. So it's basically going to look like that, which means it's going to be all the way over like that. So it looks like my intersection point is right here. That looks like my intersection point right there, right? So in this case, I would put, for that one, I would put -1, -1. So -1, comma, -1. All right. So next one. All right, let's go ahead and move on to our next one here. What on earth was that? Let's not do that. That was ugly. All right, let's go ahead and move on to which expression is equivalent to this expression here. So what I need to do is I need to take this expression. I like to rewrite my expressions, but when you do that, you got to be super careful that you don't mess up any values, right? So you got -1 y to the 4th, right? And I got 3 x to the -5th, right? Y to the -1. Now remember, if you have a negative exponent, remember what that means is that you can flip it over to the other side of the railroad tracks to make it positive, right? And I've told you the story before of the guy who lost his gal, you know, and it's a positive light change for him to move to the other side of the railroad tracks. And so anyway, I'm going to leave this y to the 4th on top because it can stay, but I'm going to move that x to the -1 to the other side. So that's going to be there, right? I'm going to make it there. It's still going to be multiplied times this 3 here. This x to the -5, I'm going to move to the top because once again, it's a negative exponent. It can move to the top. And I still get y to the 1. I can also move to the top. Now, I don't have to do it like this. There's other ways. I could actually do, remember, if you're dividing exponent, you actually subtract them. So I could do -1 minus a -5, right? I could do that as well, but I'm just going to go ahead and move them over to make them positive just for kicks and grins. And so this one here, I get x to the 5 over x is going to be 5 minus the 1, x, right, is going to make it 4. So on the top, I'm going to have x to the 4th. On the y 4th times y to the 1, if you're multiplying these of the same basis, you're going to add the exponent. So it's going to be y to the 5th now, right, over really 3. Because the x's got resolved here. So this is my final answer, which ends up being this one here. Hey, aha, victory is mine. All right, let's go ahead and do the next one. So the cost of a pack of chewing gum in a vending machine is 0.75. The cost of a bottle of juice in the same machine is 1.25. Julia has $22 to spend on chewing gum and bottles of juice for her team. 1 second. And so basically to spend on chewing gum and bottle of juice for her team, and she must buy 7 packs of chewing gum, which inequality could be used to find B, the maximum number of bottles of juice she can buy. So what this is telling you to do is, hey, look at these inequalities and see which one matches, right? Well, the total amount that she has is $22. So whatever amount she spends, it can't be over that. So I know it's got to be less than the $22. It could be equal to it, but it has to be at least less than or equal to it. It can't be greater than that. So I'm just looking at answer choices that have less than or equal to 22. It looks like these are both less than or equal to 22, but these are both greater than or equal to 22. And it doesn't make any sense that the amount you spend be more than the money you have, so I'm going to go ahead and mark those out already. So now I have the cost of a pack of chewing gum at vending machines 0.75. So it looks like 0.75 times the number of okay. So she must buy 7 packs of chewing gum. So what I have is I have my 0.75 for each of the gums, right? She has, for each of the gums it's going to be 0.75. And I need that to be times, they already told me I'm buying 7 packs of gum, right? So since I'm buying 7 packs of gum, I'm going to multiply that 0.75 times 7. And I'm going to add to the cost the number of bottles of whatever she buys. Well, it says each bottle is 1.25. And they want to know how many bottles she can get. So she makes that B, okay? So I'm sorry about the chicken scratch a little bit. I was trying to fit that in there. But it looks like it's got to be 0.75 times 7. Well, this one's 0.75 times the bottle. That actually is the wrong price for each bottle. Each bottle is not 0.75. Each bottle is 1.25. So that means B is out. The correct answer then would be D. All right, let's go ahead and continue. See if we can get some more problems in before that timer rings. Raquel has $50 in a savings jar and is putting in $5 every week. Jer has $10 in his own jar and is putting in $15 every week. Each of them plots their total savings on a graph with time on the x-axis and the total amount saved on the y-axis. Which statement about their graphs is true? Ooh, I like this one. So you got to think about this for a second. Raquel has $50 in a jar. So he's starting off with 50. That's going to be his y-intercept, right? So this is for Raquel. So Raquel is equal to that $50 plus he puts in $5 every week. So $5 times the number of weeks added to that $50. Now Jer, on the other hand, he has just $10 in his own jar. Aww. He has $10 in his own jar, but he manages to save more each week. So he ends up with $15 every week. So even though Raquel starts off with more money, Jer is perhaps making some better choices in terms of the saving department. So each of them plots their total savings on the graph, and it says which of these is right. Raquel's graph has a steeper slope than Jer's. Well, the slope of Jer's is 15. That means it's going to go up 15 and over 1 for every week. Rather, as Raquel only goes up 5 and over 1. So Raquel's graph is definitely not steeper than Jer's graph. So that one's out. It's definitely not a steeper slope, right? Raquel's graph always lies above Jer's graph. So if you think about it on the line, it's saying that Raquel's is always going to be above. Even though it starts off at the 50 here, remember, it's got a slight, not as big a steep. This one starts at 10, but it's got a much bigger steep. So it's not always going to be above Jer's graph. It does start that way, but eventually Jer's going to overtake him if he keeps up his stuff. So Raquel's graph always lies above Jer's. You could actually, if you wanted to, you could graph both of these in your calculator to see what they look like, and you'd put it in your y is equal to 5x plus 50, right? And y is equal to 15x plus 10, right? But anyway, Jer's graph has a steeper slope than Raquel's. That would be a true statement because this is Jer's graph here and this is Raquel's graph here. And so as you can see, it is a steeper slope. Jer's graph always lies above Raquel's. That's not true. Jer's graph actually starts below Raquel. So the correct answer is C. All right, let's go ahead and move on to 16. 16 says, firing a piece of pottery in a kiln takes place at different temperatures for different amounts of time. The graph below shows the temperatures in a kiln while firing a piece of pottery after the kiln is preheated to 200 degrees Fahrenheit. So it says, during which time interval did the temperature in the kiln show the greatest average rate of change? So essentially what it's saying is, at what point was the slope the greatest? And if I look at this here, it looks like the slope starts off quite steep and then it starts to even out a little bit, right? So it looks from 0 to 1, I actually have a pretty steep slope here. In fact, the gain in this part here was a gain of, in 1 hour, right? This is my 1 here. And I'm starting, it looks like, if this is 400, then this would be 200. So it looks like in 1 hour, I gained 500. So my slope in that first hour was 500. That's a lot. So that looks like a pretty steep slope. The next slope, in essentially half an hour, right? It looks like he gained another 200. So that's 200 in half an hour, which means in 1 hour it would be 400, right? And really, you could just kind of eyeball it. You can actually see that it starts to level out a little bit, right? So it looks like the steepest part is this first 0 to 1 hour. It's clearly not 2.5 to 5 hours. That's not very steep at all, right? 1 hour to 1.5 hours is less than this one, you can see. And then 5 to 8 is way, way, way not very steep at all, right? So which interval had the greatest average rate of change? You're looking at that 500 that was here, okay? All right, let's go ahead and do, and once again, really you can look at that and see. You can see that this slope here is steeper even than this slope or any of the other subsequent slopes, all right? So 16, done, yeah. Alexa, how much time is left on the timer?
You have 22 minutes left on your 30 minutes timer.
Oh, that's not right. Okay, I must have made a mistake somewhere, guys. All right, here, I'm going to do, let's say I'm going to do... Let me do one more problem, and then I'm going to call it good, okay? So this problem here, I'll have done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and let's do one more problem. Let's call it a good even 12, and then let's call it good. So a church group is planning a trip to an amusement park. They are taking their church bus, which holds up to 32 people. It will cost $25 for parking, and tickets to enter the park are $22.50 per person. The total cost for n people to go on the trip is given by the equation. C is equal to 25 plus 22.5n. So all of this talk here, they literally wrote the equation for it right there. So that's easy, right? But anyway, what's the range of the function? So the range of the function, does the people depend on, does the cost depend on the people, or do the people depend on the cost? Well, the people don't depend on the cost. Obviously, the people are going to go, and then the cost comes from that, right? So your cost then is going to be your range. So I need to think of my cost. So it's $25 just for parking, right? So the 25 is gonna be there no matter what. So if so then we just got to add on, like if no one goes, obviously you're not even gonna pay that $25, right? So it's gonna start at 0. So 0 is gonna be the minimum amount to spend, right? Now the other thing I want to look at is this data discrete or continuous? In other words, can I have like parts of a ticket or parts of an amount, or is it going to all basically just be like it can be this amount or this amount or this amount or this amount or this amount? In other words, is it going to be like dots, or is it going to be like a continual line of data? And if I look at this, it makes sense that I can have 1 ticket, or I could have 2 tickets or 3 tickets. So it looks like my price is going to jump in increments, right? So it's going to start at 25, or it's actually going to start at 0, and then it's going to be 25 plus whatever for the first ticket, so plus 22.5. So it looks like the first amount that I could spend is this $25 plus a 22.5 for 1 ticket, right? For 1 ticket. So that amount there, if I calculate that out, ends up being 47.5. So that's 47.5, and that is for 1 ticket. So I need to find a 47.5 in here. It looks like this one jumps from 0 to 1. This is actually counting the number of tickets for the 32 people. So this one's out. This one here, that would be like the domain. This one here, it starts at 0, but then it goes to 22.5. But it's ignoring this 25 right here. So that, unfortunately, is also out. This one here is continuous, which means it would be a line. It's ignoring the fact that you can only buy like 1 ticket or 2 tickets. You can't buy like 1.3758 tickets. So you can't have values for this stuff in there. So because it's not continuous data, that one's out. We're looking at discrete data. So it looks like actually they are factoring in that you could have no one go and you're still paying the parking fee. So okay, so you're not starting at 0, you're actually starting at 25. And then 25 plus the 22.5 per ticket gives me the 47.5. Let me just check one more. 25 plus 22.5 times 2. If I had 2 tickets, how much would that be? 22.5 times 2 is going to be 45, right? 45 plus 25 is going to be 70, which is this one right here. So this looks like this is a great candidate for my range of factors. It's the only one that can work, and so that is the answer. It is H.
Well, anyway, I wish you the very best on your test. We've had a great time hanging out with you. Sorry about the timer thing, that kind of messed me up a little bit. But hopefully you're a lot more prepared for this test. I suggest that you do every single problem on that study sheet. Once again, this is just the very minimum that you should do. And I'm glad you like studying with Mr. Sims. It's great having you as a study partner. But you're very quiet as a study partner, I have to say. But anyway, it's great having you as a study partner. But I want you to be the most prepared. So my suggestion, get the rest of the study sheet out. Go ahead and do it all so that you are absolutely prepared for this test, all right? Now, I wish you the very best. Have a great testing experience in the upper left-hand corner. Last thing to draw a lollipop. Draw any type of lollipop that you like in the upper left-hand corner. All right, so once again, you should have a few different things on your paper. I wish you the best on your test, and thank you once again, and good luck.